to use technology to graph 9 to the x and 3 to the 2x. And apparently, the way it's phrasing that, something exciting is going to happen. I suggest downloading on your phone, if you have not already, something like Desmos. And the nice thing about Desmos, D-E-S-M-O-S, is that on a website, it appears the same as it does as an app. They're identical. The app is free. And for when you're doing your homework and trying to figure things out, or just maybe trying to check an assignment and going, is this right? Before I hand it in, is this the right graph? You can put anything you want in, and it'll graph it. Great help through this course, advanced functions, calculus, helping a grade 9 friend with their homework, all graphing situations. So let me put in, what was the first thing we want? Y equals 9 to the power of x. And here's some help from your assignment. What you should find on all bases that are bigger than 1, you should see an exponential graph, something like this. And it goes through 0, 1 each time. It has an asymptote heading towards the negative x-axis, and then takes off like crazy on the right-hand side. Just goes right off the page, just really fast. And it's increasing the whole time, answering a whole bunch of your assignment questions. If that went by you too fast, just get your assignment out and watch that first part of the video. A lot of the stuff given away right there. I just want you to know it. So there's 9 to the x. It also asked me to graph 3 to the 2x. So I'll type that in slowly if you're learning how to type this in now. Y equals 3, and if you want an exponent, I don't really use the keyboard thing down here anymore, but you could use a little keyboard thing to make an exponent. I don't. I press on my keyboard what's called the tilde. It's above your number 6. It just looks like the little top of a house. That's computer language exponent. But you don't have to do that. Desmos says, oh, you don't have to know that. You can just hit the exponent button, and I'm going to do 3 to the 2x. And after it does that, you might be confused for a moment about what just happened. Because it's like one of them disappeared. Like, oh, can I not graph both at once? Well, actually, these little symbols over here on the left side allow Desmos to graph 2 things at once, and you can turn them on and off. So here's the red graph back again. Do you see it? And then here's the blue graph only. And then when it superimposes, you only see the latest one, the blue one. And here's the big aha moment. 9 to the x and 3 to the 2x are the same. I got so excited, I smashed my active board, which is leaving. December the 4th is Merry Christmas. This active board's going. All right, we might have to move on December 4th for a day or two. Anyways, back to here. Back to the actual lesson. What do you notice about the graphs of the 2 functions? In capitals, they are the same. And it is okay if that mystifies you right now. If you're like, how could they possibly be the same? That is okay at this moment in the lesson. It's just, maybe you see it already, why it plays out like that. It's just an exponent law, an application of exponent laws. But these 2 things are the same graph. Now this opens up a very large can of worms. That potentially, we shouldn't just use any base. We should use the smallest base, always. That's really where I'm going to go with this, is why not just use the smallest base possible so that we can compare, so we're not confused. If you're graphing 9 to the 2x, or 9 to the x, and I'm graphing 3 to the 2x, we're not surprised by putting it in the lowest possible terms. Okay? Well, we'll get to all that in a second. Explain this result. Well, does anyone want to try and explain why 9 and 3 squared are the same? 3 squared equals 9. And that might not totally explain it, but it sort of looks at it. So here's me doing the work over here. I'll switch to blue going, here's me actually doing the work to prove it. Y equals 9 to the x, I can express with a lower base. Not all numbers can. For instance, if this had been a 7, there's nothing I could do. But some numbers, you can express a lower base. There's a base inside 9 I can use, and it's 3. I could express 9 as 3 squared. And then you got to reach back into your exponent law bag of tricks and go, when you have an exponent to an exponent, you can multiply the 2 exponents. So here I have proved that 9 to the x is 3 to the 2x. I could have started the lesson that way. Could have said, listen, 9 to the x is equal to 3 to the 2x. If you sub a number into this function and sub it into this function, you'll get the same y value either way. And then showed you the graph, but I don't know, it's more dramatic the other way around. So describe how the graphs, whoa, now this is different. This is what a homework question looks like. Describe how a graph of 9 to the x and 3 to the x are related using transformations. Here's what you do. You look at the larger base first and go, is there something I can do to this to get it into a lower base? And the answer is yes. 9 can be expressed as 3 squared. And if your mental math is not good, it doesn't need to be. You just get out your calculator and you go, okay, well, 9. Can that be expressed as base 2? And you just go, okay, 2 to the power 2. No, that's not 9. 2 to the power 3. Is that 9? No, that's not 9. So 2 doesn't work. How about 3? 3 to the power 2. Oh, that is 9. It's not going to be, I'm not going to put on base 729. You know, it's going to be something you can just play around with and get the numbers. Hopefully, as you do a few of them, you get a little faster at it. What that means is, this is y equals 3 to the 2x. And I'm trying to relate it to y equals 3 to the x. There's only one transformation here. What's the transformation that's gone on here on 3 to the 2x from 3 to the x? What's that? It's a horizontal, because it's inside the function. What exponentials, inside means in the exponent. Compression, factor 1/2. No, the first answer wasn't as wrong as it might have sounded, because if it had been vertical and that had been a 2, it would have been a vertical stretch, but the only thing you missed was that, oh, it's a horizontal, which changes the 2 to 1/2. There, that's the homework in a nutshell. That's what you're going to be asked to do today, is get these things in the same base and then relate the two of them. I've got a few more details coming. If it's like, oh, I don't quite get that yet. Well, that's fine. I got more coming. But that's mostly the whole lesson on a Monday. I didn't plan it that Monday would be a nice, easy thing like this, but